Hello everyone, in this video I'm going to show you how to assemble the Filamentalist spool holder slash spool rewinder for Enrich Rabbit project carrot feeders and other MMU-like projects. So as I said, this is a spool holder. It acts just like a regular spool holder. When the filament gets pulled, it holds the spool in place and it unwinds the spool. But it's also a spool rewinder, and that's the cool thing about this project. When you're doing a filament swap or whatever, and when the Enrich Rabbit project is pushing the filament back, this also rewinds the spool, like so. So yeah, I think it's a really cool project and definitely worth considering building if you have an MMU-like project like Enrich Rabbit project carrot feeder. I'm hoping this video will help you assemble this project much easier than following the instructions on the GitHub, which I struggled with at least. So let's begin assembling a Filamentalist. And here are all the parts you will need to buy to build one Filamentalist. This is obviously excluding the filament. The GitHub repository of this project is linked in the description below, and in the GitHub repository you can find a list of these parts and purchase links. So definitely check the link in the description below for the purchase links and a list of these parts. But there are a few details that aren't mentioned in the BOM, so I recommend not skipping this part even if you're going to check the GitHub repository for the BOM. So the parts you will need are an 8mm, 80mm long steel shaft. You can find these easily on places like AliExpress or Amazon. You will need one HF 08 1412 one-way locking bearing. I wasn't able to find this in the US, so I bought mine on AliExpress from Raindew, and yeah, these are not expensive, just not that easy to source. You will need 5 608 bearings. The GitHub repository mentions MR 608 bearings. I wasn't able to find any bearings by searching for MR 608, but I don't know what the MR stands for, but the regular 608 kind seems to work just fine, so I'm assuming it's the same thing. So yeah, if you are not able to find MR 608s, you can try 608s, and you might even have these lying around if you've built some Voron projects in the past. You will need the Voron style, this ECAS something or another Bowden coupling, and you will also need this thing to lock it in place. You can find these on places like AliExpress. These are typically intended for Bowden versions of E3D V6 and V6 knockoff hot ends, and it's the same sort of Bowden coupling, so it locks the thing in place so the Bowden tube doesn't come loose. You will also of course need a Bowden tube to run between the Filamentalist and your Enrich Rabbit project carrot feeder or whatever MMU unit you are using. The length of that will obviously depend on the distance between your Filamentalist and your Enrich Rabbit carrot feeder, but it should be 2.5mm inner diameter just to reduce friction on the filament. You will need one M3 socket screw, and this can be 30mm, 35mm or 40mm long. The GitHub repository specs 35, but later in the README it also mentions the other sizes work just fine. So this is a 40mm long one. The thing you need to pay attention to with these is it needs to be fully threaded. So I had a bunch of M3 35mm screws lying around that I was planning to use, but they're not fully threaded, and you do need the thread on the entire length of the screw. So make sure the screw you are using is fully threaded. You will need one spring, and this details of the spring is in the GitHub repository. You will need one M3 washer, one M3 lock nut, one M3 Voron size threaded insert. You will need 6 M3 8, 10 or 12mm long this flush head style screw that's used in some of the Voron projects. The GitHub repository specs 12mm, and that's the size you want to use if you want to fully thread this, but you are threading this, self-threading this into plastic. There is no threaded insert, and I find long screws a bit difficult to self-thread into plastic, so I'm using 8mm long ones here, and they work just fine. You will also need the same type flush screw, but 18mm long, M3 again. Apparently 12 and 16 work just fine too, and I assume 14 works too. 14s are not as easy to source, but if you for some reason have them lying around, I'm using 18s here. And yeah, you need 3 of these. You need two of these big size 94 rubber bands, and details of this are in the GitHub repository, and details of these O-rings are in the GitHub repository as well, but you will need 2 of these per Filamentalist. So as for the tools you're going to need, you will need 2 sizes of hex drivers. I'm using screwdrivers here, but you might use an Allen wrench or whatever you might have lying around. You will need a 2mm one and a 2.5mm one. You will also need a pair of pliers. You will need something to clamp parts together. You might want to use a vise if you have that, but my vise is a bit too small for this, so I'm using this clamp. But you'll notice that the soft insert things in here, these things, I remove those because you want to clamp against a hard surface, and that will work a lot better than clamping against a soft surface. If you don't have anything like this, you might want to use a rubber mallet or something like that against a flat surface, but you know, these are not expensive and these are very useful, so yeah, I recommend getting something like this if you don't have it. You will need some tools to clean print defects, and I recommend using a file like this, and you will probably also need a knife. This is not a mandatory tool, but I find this very useful. This is a 5.5mm socket driver, and I'm going to use this for the nylock nut. If you don't have this, you might instead hold the nylock nut in place with a pair of pliers, and that should work too, but I find these much easier to use. And this is from an iFixit kit, but if you don't have this, it's not a must. You might get away with just using your pliers, as I said. And I forgot to mention this in the recording, but you will need at least one, preferably two of these axle pressing tools. This tool will help you press bearings into the holes for the bearings easier, and it will also let you have just the right amount of shaft sticking out of the bearing. So yeah, this is a useful tool to have. One is enough, two might be a bit better, especially if you're using a vise to clamp things together, but I used one and that was enough. And you only need one or two, doesn't matter, in total, not per Filamentalist. Since this is a tool, since this doesn't get installed on the Filamentalist, you don't need to print multiple of these per Filamentalist, just print one or two of these. And finally, here are the printed parts you will need to print per Filamentalist. You will need to print the rear side rollers, these two pieces that screw together. These have some overhangs inside that don't print too well, so that's one of the things you might want to clear with a knife, or you might also want to shove the steel shafts in there just to clean it like so, but the steel shaft won't actually go in here. I will show where that's used when we start assembling it. There are these two big rollers that you need to print. You might print two of these, or you might print one of these and one of these, and this is what I recommend. This roller is missing a little insert here, and that is this, and these two parts screw together. And the idea behind this is it makes replacing the O-rings on this roller, which is something you also need to print, easier. So I recommend printing this version, which has this removable part, so that you can just unscrew this, access the this roller, which will make replacing the O-rings much easier, as I said. And this is another thing you will need to clean. As you can see, this part doesn't print so cleanly, so you will need to clean this. And again, you might find inserting this shaft in there makes it a bit easier. You might also want to try using a deburring tool or a knife or something like that. Just clean it as much as you can, so that once the part is screwed in place, it sits flush, or as close to flush as possible. You might want to shove a big flathead screwdriver in here just to tighten this, but obviously don't hulk it too much because we're talking about printed plastic here. You will need these two spacers for the front roller assembly as well, so print two of these. And these black parts, you will need to print this D-shaped shaft, one of these. You will need to print this front piece, and these two C-shaped pieces. These are not identical, so these are separate files you will need to print. And the main body parts, I'm using the version that clicks into extrusions, but you might use a different version. The details of these parts are explained in the GitHub repository, which is linked in the description below. There is also a base part that you might print, but you don't have to. So yeah, unless you're planning to use this standalone sitting on a bench or something, you don't need to print that. But yeah, if you do, then there is that part as well that you can print. So let's start assembling this. So let's start by assembling this part. So this is the only thing I'm not going to show in this video, and that is inserting the threaded insert here. I'm sure you've inserted threaded inserts into parts before. You just push it in there with a soldering iron. So that's the only part I'm not going to show here. So that's the threaded insert done. Then you need the Bowden coupling. Remove this rubber part here, but make sure to keep the plastic bit in here, and push this in place. Now for this, you might want to use the 8mm shaft to apply pressure on here. I like to use just pliers because I don't I'm not too worried about the cosmetics of this part, but if you use pliers like I'm going to, there might be some, you know, it might not look the prettiest, but I think it will work just fine. So you just push this in place. There we go. This was a little more difficult in this case because I'm trying to do this in front of the camera and the tripod is in the way, but there you go, it's inserted, and you might want to put the clip in place just so you don't lose it. Next is inserting this screw through the threaded insert here, and you need to thread this all the way. So I'm going to use my ES15 just to make this a little easier, but you can use a screwdriver or an Allen wrench or whatever you have lying around. They will work. There we go. Now put this to one side and let's work on these two parts. So before we start assembling those two parts together, first of all you need to remove the printed support that's on here, but after that I also recommend filing those edges. So this should now easily go in the cutout in here. So starting with this part, insert this one of the longer screws through this hole here, like so, but don't fully push it, and put the bearing in here, like so. Now we grab the other part, insert it in place on this side, and you just need to self-thread this screw into this plastic. And yeah, obviously you're self-threading in the plastic. Don't hulk this down, especially don't hulk this down because this bearing is supposed to rotate, but you know, it's not going to be the easiest, so be prepared for that and make sure you're tightening this straight, like so. And then insert another screw in here and also tighten that fully, like so. So next you put these two parts together. So you feed the screw through the cutout here and line these two holes up. There is a hole here and the two holes here. Line these up and feed the last long flush-head screw through here, and again self-thread into the other bit of plastic. There we go. And you obviously want to make sure that you don't hulk the screw down, and you want to make sure that this part is moving freely, like so. And if it isn't, back it a little bit just to make sure that these parts are moving freely. Next, on the screw, you feed the M3 washer onto that, then the spring, then the M3 nylock nut. And I'm going to use this to tighten this. Again, you might want to use pliers or whatever you have lying around, but what you're trying to do is make sure that the screw gets engaged on the nylock bit, but you don't want it to go too far beyond that. If the camera focuses, that, there we go. So tighten this until the end of the screw is pretty much flush there. You don't want to tighten it any further because the tensioning mechanism isn't the nut end on this side, it's the screw here. So if you loosen the screw on the thread insert, this will get tensioned. So you don't need to screw the nut beyond the edge of the screw. Just make sure that the nylock bit is engaged so that it doesn't come loose. Next, we're going to work on the front rollers, and to assemble those you will need all of these parts: the two bigger rollers, the smaller roller, the two spacers, two O-rings, two rubber bands, the 8mm shaft, the locking bearing, and at least one of these bearing pressing tools. You might want to use two. So let's start with this. On this you want to put these two O-rings on here, like so. Make sure that they're not on top of each other, and this is the groove the filament will go on, and the bearing on this part we assembled will be applying pressure, and essentially the filament will be turning this roller, which is how the rewinder mechanism works. And you do the same with these rubber bands on the bigger rollers as well, and these are the rubber bands that drive the spool to rewind or whatever, like so. Do it on the other one as well, like so. I find that these bands are a little narrower than the width of the roller, but I try to get them somewhat centered and straight, and it seems to work just fine. I don't think it's an exact science, so as long as it's on there, it should work just fine. So next we grab this part again and insert the locking bearing in here. So the next step is to put the bigger rollers on the steel shaft, and this is something you will need to pay close attention to. The direction the locking bearing locks in, and the side this part with the bit that screws out goes in. So you want to make sure that this part goes in the side where when you're turning the roller in this direction, like so, the bearing doesn't rotate, it's locked. So this is in the wrong direction in this case. When it's turning this way, the bearing should be locked and it shouldn't be turning freely. That's what you're trying to make sure. Otherwise, the screwed part in here will come loose, and yeah, you don't want that. So to start with, you want to insert this spacer in here and then insert this part like so. It needs to protrude just the right amount, so you put this part in here and line those up. So let's grab the clamp. Again, you can use a vise for this. Just put it in place like so, clamp it, and there we go. This is protruding just the right amount. So you do the same on the other side. Place the spacer and place the roller like so. And again, you want it protruding just the right amount. The other one went in pretty easily. Usually it doesn't go in that easily, so you will need to apply a bit of pressure with the clamp. Just make sure everything is lined correctly. Again, I'm doing this with the tripod in the way, which is making this a little more difficult. It's not this difficult to do in real life. There we go. It's protruding just the right amount on both sides. And when you turn on this roller, the screwed part doesn't come loose. Next, we will assemble the rear roller, and this is a pretty simple thing to assemble. You will need the two bearings, the bearing pressing tool, and the two printed parts. So you start by screwing these two parts together. Next, you insert the bearings on both sides, like so. And then you grab the bearing pressing tool, put it over the bearing, and you will need to push the bearing inwards with that, so like so, and you end up with the bearing inset from the edge of the roller, and that is by design. So you need to push both bearings inside as far as they go. It shouldn't take too much force if your printed parts aren't printed too badly. Just make sure that this roller is the bearing pressing tool is aligned on the bearing. Apply some pressure, and there we go. These are good to go. So next we will assemble these parts and put the parts we've assembled so far on these, and our Filamatrix will be done. So you will need these two printed parts. These are not the same, so these are the two sides. These are separate printed parts. You will need this D-shaped shaft, the two remaining 608 bearings, and the 6 so far unused, the shorter M3 flush head screws. So start with the bearings, just push them in here. You shouldn't need to use the tool, but if you do, yeah, you can use that on here to make sure these are flush with your clamp or vise or whatever you're using. Next, you grab the D-shaped shaft and make sure the flat is on this flat and insert it in place, like so. Make sure to not twist it too much because this plastic is fairly thin. You might end up breaking it if you apply too much force. So you grab one of your screws and screw that part in place. There we go. Again, yourself threading into plastic, don't hulk it down. Now this D-shaped shaft is for the real rollers. So put this part flat on the table or some other flat surface. Don't do this in air because again, this is a thin piece of plastic. You might end up breaking it. Put the roller on here, make sure guide the shaft in the bearing, and it might take a little bit of force, but it will go in, and push it down like so. Pay attention here, make sure the shaft is properly aligned in the bearing, and then push it all the way like so. Next, you grab your front roller assembly and the front piece and you put these together. But there is one thing you need to pay attention to, and that is the direction the bearing in here locks. You want it to rotate in this direction, but not in this direction. So this is the front. You want it to not be able to rotate when you push it like so, or clockwise from the direction of the camera. You don't want it to rotate in that direction. So you put these two together and then you line the shaft with the bearing hole in here and put those two parts together like so. And then you grab your other piece and put it in place too, so on over the shaft in here and in the D here. Next, you have 5 more screws to screw. Let's start with this one. So you have 4 more screws to screw, and those go 2 on this side and 2 on this side. So I like to start with the front ones, and you will need to line this with your finger, and you might need to apply a bit of pressure against this spring essentially. So make sure the holes are lined up, and then you do this the front screws first. And only 2 screws left, but you'll notice that this part isn't sitting flat against these parts. So that's because of the spring in here. What you'll need to do is jam your finger in here, and that will line those 2 holes up, and then screw the 2 parts together. And the other side, you'll need to do the same. Put your finger in there, make sure the holes are lined up, and screw that final screw in place. And there we go, your Filamatrix is assembled. So the next thing you will do is mount this on your extrusion frame or whatever you have for your Rabbit project carrot feeder, and put the Bowden tube in, and then you will put the Bowden clip lock thing in place so that this doesn't come loose. And when you're feeding the filament, what you do is you feed it through this slit in here, and you make sure that the filament is between the 2 O-rings. So this is a bit of an awkward angle, but let's try to do it like so. And obviously this would normally be mounted, but then again you wouldn't normally do this with a tripod in the way. So you feed it in there, and you'll see that the filament is in the Bowden tube now. I'll remove the Bowden tube so you can see it a bit more clearly. So let's move it. There we go. The filament was fed in there just fine. So there we go. It's assembled. Make sure that it's working correctly. So pull the filament, make sure the spool gets unwinded, and push it back in. Make sure it gets wound back, and as you can see, it's working just fine. So this is how we assemble a Filamatrix. I said Filamatrix again, Filamentalist. So yeah, it's a bit of a complicated assembly process, and unfortunately there are quite a few screws that are self-tapped into plastic, which I really don't like. But other than that, it's a really cool project, and I'm really looking forward to using this on my Rabbit project carrot feeder build, which is going to go on my Voron 2.4 Doom Cube. So definitely stay tuned for that. That's it for this video. I hope you found this video useful. If you did, please leave a like down below, and thanks for watching.